Okay, so moving forward with the idea of naming alkenes, and this is pretty similar to alkanes, naming alkanes, but we'll do this in detail. So let's talk about the first thing that we're going to talk about is prefix and the suffix part. And from the previous chapter, we know that the prefix tells you the number of carbon atoms, and the suffix, this tells you the homologous series it belongs to, right? So that can be ene, that's for alkene, that it can be ene, that is for alkene, it can be OL, which is alcohol, and it can also be OIC acid, which is carboxylic acid. Okay, so if I were to draw a few structures, let's say we talk about something like this molecule. If we were to talk about this molecule here, and let me draw a few more. So something like this, double bond here. This is 1, 2, 3, and 4, and this is 1, 2, 3, and 4, and this is 1, 2, 3, and 4. Okay, this is 1, 2, 3, and 4, and 1 H here as well. Okay, so one is this, and let me draw one more. Yeah, so let me draw one hydrogen here, 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 and one hydrogen here. And now if we were to name these molecules, let's say we start naming from this one. So this is a 2 carbon molecule, and we know that 2 carbon, the prefix then becomes eth. Okay, and since this has a double bond, we know that we're studying the alkene molecules, so this becomes ene. So this molecule is called ethene. If we were to talk about this, now this is 3 carbon. 3 carbon corresponds to a prop, and since this has a double bond, this is an alkene molecule, this is going to be called propene. And if we were to talk about this, now this has 4 carbon molecules, which means it's going to be called bute. And since this is an alkene molecule, it's going to be butene. Okay, it is as simple as that. Okay, one of the things that you need to keep in mind, let's say if I were to draw this structure again, like this, and if I were to change the position of the double bond, okay, let's say the double bond comes here, right? So the question here is that, does this make any difference? Like the double bond in this one was here, and now the double bond is here. So does it make any difference? And the answer is no, it does not. Why? Because if you look at this molecule, or if I tell you the general rule, we start counting the carbon atoms from the place where the double bond is the closest. Okay, so if I were to talk about this molecule, here the double bond is the closest to this carbon. So we start counting from here. So this is 1 carbon, this is 2 carbon, and this is 3 carbon. And if I were to talk about this, now here the double bond is this place, which is near to this carbon molecule. So we start counting from here. So this is 1, this is 2, and this is 3. Now if you notice, here the double bond is at the first carbon, and here the double bond is at the first carbon, which means is that it is at the same place, at the same carbon. Okay, so because of the counting, the carbon is the same, we call this the same molecule. These 2 molecules are the same molecules. Okay, this is also what? This is also propane. Okay, but if I were to talk about this molecule, let's draw this molecule. Okay, so let's draw this, and let's say the position of the double bond now comes here. Okay, now this makes it interesting, or it does not, because still, if you notice here now, the double bond was here, so we start counting from this place. So this is 1, 2, 3, and 4, and now the double bond is here, so we start counting from this place. So this is 1, 2, 3, and 4. So this is still is at the same position, right? So we're gonna call these 2 molecules the same thing. Okay, these two molecules are the same molecules. These are what? Same molecule. These are both butene. But what if I were to draw something like this? What if I were to draw something like this? I'm not drawing the hydrogens, okay? You can just see it for yourself, right? Okay, so what if I were to draw this molecule? Or let me just draw the hydrogens real quick. So this is 1, 2, 3, and this is 1, 2, 3, 4, and this is 1, 2, 3, and 4, and this is 1, 2, 3, and 4. Okay, so now where would we start counting? So if you notice, the double bond is here. So if I start counting from this place, so this is 1 carbon, this is 2 carbon, this is 3 carbon, this is the 4th carbon. But if I start counting from this place, so this becomes first carbon, this becomes the second carbon, this becomes the third, and this becomes the fourth. So no matter where from I count, it's coming on the second carbon from here, and it's coming on the second carbon from here. So that means that there is no differentiation. No matter if you count from there or this side, it's coming on the same carbon. Okay, what differs? That is the naming. How? Because now what we're going to say, we already know that this is a but because it has 4 carbons, and since it is an alkene molecule, so it's going to be an ene. What is the difference between this one and this one? Both of this. So if I were to name this correctly, this is going to be called but-1-ene. And this 1 here represents the place or the carbon where the double bond lies. So in here, in this molecule of butene, it was on the first carbon, so we call it but-1-ene. And in this molecule, since it is on the second carbon, from the both places it is on the second carbon, we're going to call this what? We're going to call it but-2-ene. And these two are isomers of each other. Okay, we're going to get into isomers in a while, but this is just for the concept. Okay, and let me just I hope this thing with but-1-ene and butene is clear. Okay, because it was on the second carbon, because the double bond was on the second carbon, we call this what? We call this but-2-ene. Okay, and let me just draw the molecular formulas for this real quick. So this is C4, and 1, 2, 3, 4, 5, 6, 7, 8. So this is C4, it's 8, and this one is C3, and it's going to have 6 hydrogen molecules. And how do I know this? So let's say if I were to give you something like a molecule as, let's say, if I were to give you C5 and I were to give you C5H10, okay, and I would ask you that, okay, is this an alkene molecule or not? And how do you know that? So you use the general formula at this place. You're going to use the general formula for alkenes, which is CnH2n, and we're going to place this value of carbon, which is the value of N. So this is C5H2 into 5. So this becomes C5H10. Okay, so this now satisfies the equation, which means that this is going to be an alkene molecule. All right, and the first molecule that we draw, which was this molecule, is something that we call this ethene, and the molecular formula for this is C2H4. What is the difference between the alkene and alkene? So if this was an alkene molecule, it would be C2H6. Why? Because in alkene we have a single bond. Okay, in alkene we have a single bond. So when you have a single bond, the tendency to make 4 bonds becomes different. Like if I were to draw the same structure but for an alkene, so alkene would be something like this. Why? Because since now you have a single bond in the middle, you can attach 2 more hydrogens, or 2 more hydrogens are going to be attached in place of that double bond. And this is one of the reactions which we might have already studied. I don't know, but I don't remember quite. But we're going to do that in the future as well. So here, because we have a double bond, we cannot attach 6 hydrogens. We can only attach 4 hydrogens. So 1 bond is here, 1 bond is here, 1 is here, 1 is here. That makes it 4 for this carbon. And this 1 is here, 1 is here, and 1 is here, and 1 is here, which makes it 4 for this carbon. So this is now fully satisfied the equation, and this is how we name alkenes. Okay, all right.